Hi, glad to see you again. Here we are in a basement in the bowels of the New York State subway system in a small room isolated from the coronavirus. Today is 3/20/3/20 and you do have the notes which we sent to you. Please follow the notes. I am going to follow the notes very carefully. If there's anything extra, you can add it right on the notes. Today we're going to cover a couple of topics, but first we want to do one related to number 8 on the take-home test, which talked about asymptotes, and we'll get into those in a minute. But asymptotes involve rational functions. Right now we are skipped all the way to Section 10.5. We will move back. We have already covered Section 10.1 and 10.2. Now, rational functions are functions which have a denominator. You have a function in the numerator, function in the denominator. These are polynomial functions, anywhere from straight lines to quartics to multi-powered. The only requirement is that the denominator cannot be equal to 0. If it is, we have an asymptote. In general, since these are polynomials, we can have a polynomial that reads an xn, n is the power, all the way to a1x and a0, which is the constant. The denominator can have a bm, which is the coefficient. M is the power of the denominator, all the way out to b0. What we are interested in is the n and the m, which is the power of the first term in both the numerator and the denominator. So we're talking about asymptotes. Asymptotes were covered in QBUS-110. They're places where the system heads toward a particular number but never really reaches it. There are two types of asymptotes, vertical asymptotes and horizontal asymptotes, that we're interested in. So let's take an example to start with, one pretty easy. We're going to have f of x equals 2x minus 1 divided by x plus 2. Now we're going to look at the vertical asymptote. I'm not going to write this all the time. I'm going to call this VA. The vertical asymptote pretty much says, very simple, as x approaches some constant a, then the value of f of x approaches plus or minus infinity. Means that the value of f of x never hits anything. Horizontal asymptotes and I'm only going to write this once. Oh, notice it's a long. I'm going to call that HA. Ha ha to you, because this is the hardest one to find. And we're going to say here as y, or f of x, approaches b. We can call, I'm sorry, well, let's erase this because I called it f of x. As f of x approaches some constant b, then x approaches plus or minus infinity. So there is your vertical asymptotes and there is your horizontal asymptotes. Well, that's all great, but we want to know how to find them. How to find them given a specific rational function. That's our purpose here. These are great definitions, and you'll see what they mean as we get there. But let's talk about how to find them. I will be a little bit more sophisticated than we were. Since you have these in your notes, I don't have any problems erasing this without waiting too much. The only thing not in your notes was this little vignette here. So let's take our example f of x, and if you like, we can call it y. And it's going to be 2x minus 1 over x plus 2. Okay, let's find the vertical asymptote. The VA, where we find that is to set the denominator equal to 0, and we're going to solve for x. So x plus 2 equals 0. So x is going to equal a minus 2. So this is our vertical asymptote. And we'll see what that means when we draw the graph. And now let's find our horizontal asymptote. This is a little bit harder. This involves the m and the n that we taught. Well, if you look at the powers of the first term in both of these, they're 1. So in this case, m equals n. All right, so let's look at some rules. Rules for finding horizontal asymptotes. All right, the first thing is, turn your page. This is on your second page. If n is less than m, then what do we have? Then our horizontal asymptote is at y equals 0. This is just a simple cookbook recipe. You don't even need any thought for this. No, I can't find my eraser is right behind me. As you can see, this is a very long but narrow board. But B, if n equals m, the case we have here, then the horizontal asymptote is at, we have here, y equals a to the n over b to the n. B to the m. Now notice, a to the n, if you look back on page 1 on your notes, was the coefficient of the first variable x1. B to the m was the coefficient of the first variable in the denominator. So here, this would be a to the n is what? A to the n is going to be equal to 2. And b to the m is going to equal to 1. So we have a horizontal asymptote at y equal 2 in this case. All right? Now C, suppose you're going to like this one. Well, if n is greater than m, you're going to have no horizontal asymptote. Horizontal asymptote does not exist in this case. So there are no horizontal asymptotes. That's pretty easy. So in this case, so for the case of f of x equals 2x minus 1 over x plus 2, we know vertical asymptote x equals minus 2, horizontal asymptote y equals 2. All right, let's see if we graph this. So let's graph this. This graph is on your paper there, so you can simply follow along. This is 2, 4, 6, 8. So we're going to 2, 4, 6, 8. 2, 4, 6, 8. Minus 2, minus 4, minus 6, minus 8. And minus 2, minus 4, minus 6. This is a little sloppy here. I don't have a lot of space here. Okay, so let's use another color pen to draw the asymptotes. And I think I have a handy blue pen here. So an asymptote is defined by a straight line. So if you look at the straight line x equals minus 2, that's over here. That is the vertical asymptote. Notice vertical asymptote is a vertical line. Now if you look at y equals 2, notice that's when y equals 2. All right, so at all levels of x, y equals 2, that's going to be a straight line like this. Notice that is a horizontal line. That's why we call it a horizontal asymptote. Now I drew the asymptotes. Let's see what the graphs look like. Everything is falling down. This is not really set up for this type of procedure. Eventually, we'll get on with it. Right now, this graph looks like this. And this graph looks like this. Now let's examine this graph. What happens as x approaches infinity from the right? Notice x approaches minus infinity. So what do we have here? To the right, it's approaching y equals 2. To the south, it's approaching x equals minus 2. If we look at this part of the curve, from the north, it's approaching x equals minus 2. As it goes this way, to minus infinity, it's approaching y equals 2. And there are your asymptotes. Notice the asymptotes don't approach anything. The asymptotes don't ever hit y equals 2, and it never hits x equals minus 2. So these are not really solutions to these equations. Now, because of this, you might wonder, of course you might not wonder either, only math people like us wonder, how are you going to get optimization using rational functions? Well, when we talked about optimization, we talked about maximizing profit at a particular x or minimizing costs at a particular x. So let's look at, before we do that though, let's look at a couple of other examples of asymptotes so we have this down. I'm going to erase the board now, and we're going to be on your notes on page 3.